The system that we're proposing of capturing carbon from the smokestacks, processing it, turning it into a new building material, and then shaping those materials to be more efficient in their uses in buildings and roads and bridges, it's complicated. There are many steps in this process. And what UCLA offers is a brilliant set of engineers, material scientists, economists who have been working on pieces of this problem for their entire career.
So the central theme of what we're working on is really upcycling. And when we say upcycling, what we really mean is taking something that would typically be a waste and converting it into a beneficially utilized material. So the first circumstance I'll speak about is carbon upcycling. So we're taking CO2, which is typically a waste which is emitted from the combustion of coal or natural gas or during production of cement, and we're actually being able to reutilize it to produce building material.
This technology tackles global climate change, which is one of the biggest challenges that society faces now and will probably face over the next 50 years. What we are aiming to do with this technology is capture a much higher percentage of the carbon that's emitted and then take it and use it in an economically valuable way to replace a very carbon-intensive material, cement, with a much more environmentally sensitive and energy efficient material.
The approach that we're trying to propose of how you really try and look at CO2 once again is you look at it as a resource that you can reutilize. So what we're trying to do is take carbon dioxide and convert it into a building material.
We know how to capture the carbon, we know how to improve the efficiency, we know how to shape it with 3D printing, but we need to do all of that at the lab scale now and begin the process of actually increasing the volume of material and then thinking about how to pilot it commercially.
The big challenge that we really foresee with this is we're not trying to develop simply a building material. We're trying to develop a process solution. We're trying to develop an integrated technology which goes right from CO2 to a finished product.
It can change the economic incentives associated with these power plants and their operations and turn the smokestack flue gas into a resource that we can use and that they can use to build up their cities, extend their road systems, build new bridges that they need and things like that. So it takes what was a problem and it turns it into a benefit in a set of products and services that are going to be very much needed and valued.
As a university and as one of the leading universities in the world, we see ourselves having a blue sky approach. We see ourselves wanting to develop technologies that might be considered fanciful at one point, but become reality very quickly. We see ourselves looking at a blue sky and saying we're going to come up with ideas which will change the world.